This lesson is one of my absolute favorites, factoring by grouping. This method is great for visual learners, so if you're good at spotting patterns, you're going to like this one a lot. Let's get started. Today we're going to use grouping to factor polynomials, and as usual, we start everything by looking for the greatest common factor, so if you need to brush up on that skill, go ahead and review. So what is the factoring by grouping method? It's a strategy to regroup terms so we can use some of the other methods that we've learned. So let's say we have this polynomial. It has 4 terms, and you haven't figured out how to factor those, so yikes. Well, using this method, we can transform a 4-term polynomial, better known as a quadrinomial, into an easily factorable binomial. Does that look better? You got it. This is easily factored using the greatest common factor method. So let's get. We need to factor x cubed plus x squared plus 4x plus 4. We know to look for a GCF first. I don't see one, so let's move on. This has 4 terms. It needs to be grouped into pairs or triplets. I'm going to try 2 pairs. I'll add a line here to help me see, and I'll look for a GCF on either side of the line. On the left-hand side, my GCF is x squared, leaving x plus 1. On the right-hand side, my GCF is 4, leaving x plus 1. Now, I can find the GCF of this new binomial expression, which is x plus 1. I'll bring down my binomial, and what's left over on the left-hand side is x squared. On the right-hand side is plus 4. And we're done. Let's try another one with a twist. I don't see a GCF to start, so I'll start thinking about the order that's going to help me the most. The first 2 terms don't have a GCF, so I'm going to have to move some terms around, and I'm going to switch the second, third, and fourth terms. Watch carefully. 2 things. There are a lot of ways to get grouping problems right, so if your choice doesn't match mine, that's okay as long as you can find a GCF. And number 2, you have to keep trying a few different grouping methods sometimes, so try not to get frustrated if your first attempt doesn't work. Just keep trying. Adding my helpful bar, I can clearly see that the terms on the left have a GCF of 3x, which leaves y minus 2. On the right side of my bar, I have a GCF of 2, which leaves y minus 2. Now I see y minus 2 as my GCF of my new binomial expression. Let's factor. I'll pull down my GCF, and on the left side of the bar, we have 3x. On the right side of the bar, plus 2, and we're done. Here's our third example. I'm looking how to group terms, and ooh, gotcha, this has a GCF. So let's take that y out first. The remaining polynomial has 4 terms, and I can see I'm going to use pairs. Adding my magical line and keeping the y outside of my brackets, I'll look for a GCF on either side of the line. The first 2 terms have a GCF of x, which leaves x squared minus 1. The second 2 terms have a GCF of positive 5, which leaves x squared minus 1. Now we need to find another GCF in our new binomial expression, which is x squared minus 1. I'm going to factor again using the GCF method, and then I notice, x squared minus 1 can be factored again using dots. So I'll factor using dots, and I'm good to go. Okay, what about our fourth example? S squared minus 4t squared minus 4s plus 4. I don't see a GCF. I'm going to think about my correct order, pairs or triplets. Now I have a special triplet in here, a perfect square trinomial. I just have to put some stuff in the right order. Let's see. Boom. There we go. So, adding my helpful bar, I've got a triplet on the left side of the line. That's a perfect square trinomial that can be written as s minus 2 squared. I will write it as s minus 2 squared, and then do you notice? Dots. Okay, so our next step is actually to factor again using the difference of 2 squares. So s minus 2 and then 2t, and we are finished. Okay, so it looks like our factor tree is almost complete. We learned how to factor by grouping, And the goal is to gather our terms so you have a binomial or a trinomial expression that can easily be factored. We do that by grouping into pairs or triplets, and then we use one of our old factored methods. If we have a binomial left, we can find the GCF of that expression. Now, keep in mind this method requires tenacity, especially if you're working with triples. So don't give up if you struggle the first few times. You'll keep improving the more you practice. Next up, the sum and difference of cubes factoring method. I'll see you in the next one.